Hi, it is pathfinding algorithm and it is one of the most difficult algorithm, but I will make it super easy. I have written so much comments so you can understand. You can find this code on my GitHub account. Okay, what is A star algorithm? So it is one of the pathfinding algorithm. It gives you the shortest path between two places or two distance. uh, okay, you must have used Uber and you must have wondered why the Uber driver is taking that road. You have not told him to take that path. How he knows that this is the shorter path? So for that they uses pathfinding algorithms, and one of the pathfinding algorithm is A star algorithm. Okay, so let's see. Here in this program we are trying to find shortest path from A to J. So if we will run this program and check the output, see, it is telling that path is found and the shortest path from A to J is, wait, A F G I J. So if we want to reach to J from A, then we should take this path F G I, because then we will reach like fast, because this path is short. Okay, so see how this program works. So I have defined a function A star algorithm. It will take a starting node and a stop node. See, what is the starting node? A. And what is the stop node? J. Let me explain this part also before diving into the actual A star algorithm. See, this is the information which have been provided to us, this heuristic information and graph nodes. So graph node is a dictionary. What it means, let me explain you. See, A is here and it is a key and the value is something like this, B6 F3. What it means that from A to B, if we want to go from A to B, we have to travel this much distance, which is 6. And if we want to go from A to F, we have to travel this much distance, which is 3. So likewise we have distance mentioned and it is actual distance, and this is heuristic function. It also gives distance, but it gives approximate distance. Now see, a starting node is A and ending node is J, right? We want to go from A to J and we want the shortest path. Now A is 10. Why A is 10? See, we want to go to J. Now how much distance we need to travel to go to J? We need some value, right? It can be wrong, that is fine, that is totally fine. So here the value is 10, which means we have to travel a lot if we want to go to J. But at some point we reached the J. Okay, we wanted to go to J and we reached the J. Then how much more distance we need to travel to reach to J? See, we have already reached a J, so why we need to travel more? That is why here J value is 0. Okay, I will explain what heuristic means, and this value does not need to be correct, it need to be relatively correct. Okay, so if we increase the value of 10 by 100, then we need to increase all the value by 100, because it doesn't matter what the value is, relative value should be fine. I mean, relative value should be correct. Actual value does not matter, it is approximate value. So these are the things which are provided to us. Now we can go to our algorithm. Let's see. A star algorithm takes a starting node and a ending node. A starting node is A and ending node is J, and it will find us the path which is shortest between those 2 points. Okay. Throughout this program we will assume we are going from Delhi to Mumbai. Let's see what this line says. This line says that here we are creating a set, where in set we are inserting a node which is starting node, and we are calling it open set. Why we are doing that? So see, I have written all these comments, so if you want to refer the codes you can see it. It is on my GitHub account. Okay. So open set is set of nodes from which we can choose current node or best node. Okay, so open set is like a path which we have not yet traveled. Let me give you example, you will understand clearly. See, if you want to go from Delhi to Mumbai, now you are in your house in Delhi. You came out of your house and you find that there are 5 roads, and all road can take you to the Mumbai. Okay, so all the 5 road can be your answer, because you have not checked which road is best, which road will take you to Mumbai sooner, which is the shortest road. You don't know, right? So you need to check all the nodes. So that is why we put all such nodes which we have not yet traveled, which we have yet to check, into the open set. Okay, what is the closed set? Okay, so suppose you are in Delhi, you have to go to Mumbai, and you have 5 roads, the same example, but the one road, when you started traveling, you chose one road. Okay, I want to go to this road from this road, but that road had what roadblock, maybe there was traffic jam or something, so that road was not working, so you cannot reach to your destination from that road. That road is useless, isn't it? So that road will go into closed set. Like, I don't want to check this road, if this will give me the shortest path or not. I don't want to know that. Another condition is that, see, if you are going from Delhi to Mumbai, and same example I will give again and again, it is easy to understand. So, and that one road, you know, that is longer than the other 4 nodes. If you have 5 road and one road is taking a lot of time, you know that, then you don't want to go to that road also. So in that condition also we will put that road into closed set. Now set contains a lot of path, okay, but it won't contain any duplicate path. That is why we have used set. It is similar to dictionary, but it don't contain duplicate. Okay, now G is equal to curly braces. What does it mean? What is G? So it is a term, it is short form of G score. Why they chose this word? It is used for storing the actual distance from a starting node. Okay, so don't what should I say, G score is just a distance which says how much actual distance you have traveled from the starting node. Like, there are 2 type of distance. Like, if you want to go from Delhi to Mumbai and you went to some place which is between Delhi to Mumbai. Okay, so you have traveled some distance to reach that middle place, so that distance will be stored in G. But there is also a distance which you have not traveled, which you need to travel in order to go to Mumbai. So that distance won't be stored in G. It is used for storing actual distance. Why this terminology is used, it is not relevant here. You can name it anything, it doesn't need to be G score. Okay, parent is equal to curly braces. Here also we are creating a map, or you can say dictionary. It will keep track of parent. Now again we will see this example. We want to go from Delhi to Mumbai, isn't it? Now we have reached the Mumbai. So from where we came will be the parent. Like Delhi will be parent here. Okay, so let me show you something like here. Okay, from we went from A to B, isn't it? Then the parent of B will be A. Or if we went from A to F, then parent of F will be A, because parent will tell from where we came. Okay, what was the previous location we visited, that is parent. Okay, G of a start node is equal to 0. Okay, see, we started from Delhi and we want to go to Mumbai, right? But we have just yet started, we have just came out of the house, we have not actually traveled any distance, right? So that is why the distance of a starting node is 0. Okay, the actual distance traveled when we reached the starting node is 0. That is why. Now parents of a start node is equal to start node. What does this mean? This line number 7. See, we started from a start node, right? So from where we came? Nowhere, right? We came from a start node only. We have not yet traveled. That is why parent of a start node is a start node. Okay. But if we go from A to B, then the parent of B will be A. But we are on A only, so A will be parent of A. Now we will see this line. While len of open set is greater than 0. See, the open set contains all the path which we have not yet checked if it is correct path or not, if we should go from this path or not. So here, like if you are in Delhi and there are 5 paths you can take to go to Mumbai and you have not taken any path yet, so open set will contain all those paths. Okay, n is equal to none. Okay, see, we create a node which is n. Okay, this may be the best path which we can use to reach to our destination, but right now it is empty because we have not yet started traveling. But we assume that n can be our answer, but we have not yet traveled, so that is why we make n is none. It is our current node. Okay, it is the path which we have taken but not yet taken. We will take in this line. See, for v in open set. Now open set, what it contains? Okay, Right now open set contain nothing. Or a start node. Yeah, open set. In the beginning of program we have open set. There is one path in open set, and that is the starting path. If we want to go from one place to another, then we can say that we have to start from where we already are. That is why we started from a start node. So for v in open set, okay, so it will check all the path. What is v? Like if there are 5 road from your house to your friend house, then all that 5 road will be v. Like Delhi and Mumbai example only I will take. If we want to go from Delhi to Mumbai, and you came out of your house, there are 5 roads, then all the 5 roads which are there will be in v. Okay, if n is none, or g of v plus heuristic of v is less than g of n plus heuristic of n. So see what it means. If n is none, it means that we have not taken any path, so whatever we get we will put in n. Okay, whatever path we will get. So in open set we have a starting node, so a starting node will become our path for the first iteration at least. Okay, but what if open set is empty? Then the program won't go to all these places. I am like highlighting it. See, program won't reach these part of code, and we will reach here only. Okay, if n is equal to none, path does not exist. We assume that n was our answer, but we was not able to find any path. Maybe all the routes which was going from our house was blocked. In that case we was not able to travel on any of the 5 road, and we say that path does not exist. Okay, or if we came out of our house and there was 5 road, and we reached the final destination which was Mumbai. In that case we will return the answer, but we will see that in later part. I just wanted to tell you. Okay. Back to the program. Here now let's understand this one. GV is the actual distance. G is the actual distance. Okay, we are using this formula. F score is equal to G score plus H. F score is a distance and it is sum of G score plus H. What is G score? It is actual distance which we have already traveled, and H is the approximate distance which we may need to travel. I will explain heuristic again. Look, go on the top of your house building. I mean, just assume you went. Don't go. Now you may find any two building, right? Then look at the building which is closer to your house and give it some distance. Let's say 10 kilometers. It's fine if the distance between your house and that building which you have chosen is not 10 kilometers. Like the distance between the house and your house is something, it doesn't matter how much. Let's give it some number like 10 kilometers. Then pick another house which is away from that closer house which you have earlierly chosen. Okay, so no matter what the distance is from that farther house to your house, it will always be greater than the distance which is from your house to nearer house, right? That is why heuristic value don't need to be approximate. It will work no matter how big or small is, or how incorrect this value is. The algorithm will work, because the distance to the closer house will always be less than the distance to the house which is not close to your house. Okay, so here we are calculating the sum. Okay, the actual distance which you have traveled plus the distance which you may need to travel. Okay, this is n is the previous path which you have taken, and v is the path which you are going to take. Okay, so what we are calculating here, gn plus heuristic of n, it means we have traveled this much distance gn, and we need to travel this much distance heuristic of n. So it is one distance, it's sum. Okay, keep that in mind. Now we have, if we take this gv distance path, v path, then it means that we may need to travel this much, or we have already traveled this much distance if we have taken that path in the past. Okay, so we have already traveled this much distance, or we may need to travel this much distance, but this is the actual distance, not some approximate distance. Okay, and this is the approximate distance which we may need to travel if we take this new path. V is the new path and n is the old path. Okay, I will explain it again. N is the old path, and we have traveled this much gn, g of n, and we need to travel this much. gv is the new path, we have traveled this much. If we have taken that path in the past, then we have traveled this much, or if we take that path in the future, then we need to travel this much, but it is a actual distance, and we need to travel this much also, which is approximate distance. We calculate both distance, this gv plus heuristic of n and gn plus heuristic n, and if the new path, the distance which we get from new path is less, then that path is better now. Then we should take v, because v is telling that you don't have to travel long distance to reach your goal. So we created n node, and we wanted what inside n node? The distance which is less, the distance which is better. Okay, so if this case happens, that the path which we have found will take less distance, then we will say that the current node should be this only, because it is better. But let's see that we have not yet traveled any path, n is none, we just came out of our house. Then whatever we get, whatever path we get, we will say that it is better, because something is better than nothing, right? So in that case we will take n is equal to b. Now let's see this part. If n is equal to stop node, or graph node of n is equal to none, what it means, that if n, the path which we have taken, became the path where we have to reach, where we have to go, like we have taken a path to go to Mumbai, and if we have reached Mumbai, then we don't need to do anything. Okay, so we don't need to do anything, we don't need to go to this else part to calculate what could be the better option for us. We just give our answer, we go here and give our answer, but we will see that later. Okay, but if we have not reached our destination, then we will do this much of work, and only this much is like the part which you need to understand. The rest of the code is like really easy. it is also easy. It's not like it's difficult. See, for m comma weight in neighbor of n, what it means that n is Delhi. We are trying to go from Delhi to Mumbai, right? And we found that when we came out of our house in Delhi, there are 5 roads, okay, and that is m, all the 5 roads, like first road, second road, third road, these are m, okay, and each road has its weight. Like when the first time for loop will run, it will take one of the 5 road, okay, like first road, it will become m, and what is the distance, actual distance which we need to travel in order to reach Mumbai if we take that road, first road, okay. So this is m and this is get in, okay. Let's see this again, how we are getting the value of m and weight. We are searching it in get neighbors of n. It was already given to us in the question, okay. We will go to this function. This function, we told that, see, I am in Delhi and tell me where I can go. So this function will tell, okay, let me search in the graph node. This is the graph node, here it will search. So it will say, okay, you are in Delhi, let's see, A is Delhi, okay. So it will say, okay, you can go to B and you can go to F, and I will send you both B and F. See, here this B will become M and this 6 will become weight in the first for loop. This F will become M, this 3 will become weight in the second for loop, okay. Something like that will work, and it will return where we can go. Now let's go to that place from where we have started. Yeah, so we try to find the neighbor from the current path. From n, we are trying to find the neighbor. We got one of the neighbor or one of the road from, we are trying to go from Delhi to Mumbai, and we found one road. Let's say that first road is M, and if that road is not in the open set is a dictionary which contains list of all the path which we have not yet traveled, which we have yet to discover, okay. So if we have not traveled that road, then we should travel that road to see if we can reach to our destination, or if that road is too long, if that road is blocked. See, so that is the first condition. What is the second condition? M is not in the closed set. What it means, that what does closed set contain? Closed set contain all the path which we have checked and we said that it is not good path. Maybe that path was blocked, or we know that that path was longer compared to some another path. In that case, all the path we later in the program we add to the closed set. So we will reach this path, this part of the code, only if we have not yet explored our path and we have not yet decided that path is good or bad, okay. So in that case we will add that path to open set, okay. We have not yet traveled that path to decide if it is good or bad, so add that path to open set, okay. So we assumed that n was the path. From there we went to m. So what will be the parent of m? N, right? Because we traveled from n to m. That is why parent of m is n, right? We were trying to go from Delhi to Mumbai. So when we reached Mumbai, we asked from where we came. Who is our parent? Means from where we came. So Delhi is our parent. That is where we came from. Don't take it personally. Okay. So that is why we are doing this. Now let's see. I don't live in Mumbai or Delhi. Okay. GM plus is equal to GM is equal to GN plus weight. Why we are doing this now? This may take some time to sink in, but it is not difficult if you will think about it. See, we have already traveled this much distance, Gn, because this is the place from where we are coming, right? So we have already traveled. We may need to travel this much distance if we want to go to m, isn't it? We may need to travel. So when we will go to m, what will be the distance which we have traveled? Gn plus weight. Okay, because if we will travel this distance, which is weight, then only we can reach m. And we have already traveled Gn distance. So if we will add these two now, it will equal to Gm, which indicates that we have traveled this much distance, and we are actually updating this distance, Gm. All right, when we will come into this part of the code, see what were we doing here? We were searching for path, neighbor, right? We were searching for neighbor, and we found a neighbor. Okay, but that neighbor is already in the open set, which means we have previously traveled that path. Here I am talking about. If we go here, then this means that we have chosen a path which we have previously traveled. But why we came here again? Because maybe due to some reason we found that other path was not good. That is why we came to this path again. Okay, so if we came to this path again, then we need to update its distance. Okay, how we will update this? The same logic, but we will check if this path is better or not. Okay, we are coming to this path again, then we will check, right, if it is better to go on and not. See, here in this line of code, Gm is greater than Gn plus weight. Okay, so it means that if we are going for Gm, but if the distance which we have already traveled is less, then we need to update it. Then Gm become Gn plus weight. Here we are updating the Gm. Okay, why we are updating it? Because previously what we thought now, that this path is long, but when we compared it now, we found that this value Gn plus weight can give us a smaller distance, If this can give the smaller distance, then why we are keeping the bigger distance of GM, right? Update the GM, right? Because this distance we found that is a smaller, and we want a smaller distance because we want shortest path, and that is why we update GM is equal to GN plus weight. You will understand these two lines of code if you will do the tracing. See what you should do now, like click here, see it got highlighted in red, see it got highlighted, then click on this red bug button. It is looking like bug. All right, if you will click here now, it will show you the values, write to it, and then you can like know how the program is working. But just know here that if we previously we thought that this part is bad, but we found that this distance is a smaller, okay, and if we go from this path, we can use this distance because it is a smaller, so we will update it. And parent of m is equal to n, because we are coming from n now. So what will be the parent of m? N. The same logic. Then we will go to this part. If m in closed set. Okay. We came to this path second time, right? If we came to else part, which means that after going to some other part, we found that oh, m was smaller, we should go there only, right? So m here may have been in closed set, right? Because we are coming to this path again, because we were not able to find better path, so we need to remove it from closed set, because closed set contain all the path which we thought is bad. That is why we need to remove it. At the same time, we need to add this to open path, which means that oh, I can take this path to go to my home, right? If n is equal to none. Okay, so we have done all the whole thing. Even after checking all the neighbors, see, we came out of the while loop now. That was the difficult path. Now only easy part is there. See, the most challenging line of code is this. If you will understand this now, these two lines, then there is nothing in this code. And the best way to understand it is debug it. See where it is going and from where it is coming. By you can do that by debugging. You will understand this line clearly. But for now you understand this. I hope you understood this. If n is equal to none, we tried to find neighbor but we couldn't find neighbor. We are still at n is equal to none, which means that path does not exist, right? Then we will return none. Okay. If n is equal to a stop, we try to find neighbor and n value became to the stop node. N by value became a stop node. In that case, what we will do, that we will say that we got our answer and we are ready to show the answer. So we will keep all the answer in one array. That is why we have created path is equal to this 2 square braces. What this line do? It is easy thing only. while the parent of n is not equal to n. See, the n is equal to a stop node, and you must have seen that we are keeping track of parents. Okay, so while if the node is not equal to parent, then we will add that node to path. Why we are doing that? So we came from Mumbai, we came from Delhi to Mumbai. Now if we want to know from where we came, we need to search for all its parent, right? If we search for all the parents from where we came, we will get the path, right? Until when we will search for all the parents? When the parent become equal to parent, which means that we came to starting node. You must have seen that a starting node is equal to a starting node. Parent of a starting node is equal to starting node. If this condition happen, this for while loop will stop. Alright, so until that happen, until parent become parent, which means we have some parents, which means we can add that to our answer. That is why path dot append n we have written here, and n become the parent of n. See, we have added that node to our answer, but now we need to update the n. Okay, so the parent of n will become n, because we have already added n now. So why we will need to keep information about n when we already got the answer, right? We are going back now to find the path. Remove that n. Now n became the parent of n became the n. Now we will keep traveling in this while loop until n become like parent of n, which means we have searched for all the parents. Okay, when that will happen, we will come to this line, path dot append of node, start node. Finally, if that happen, that node parent become the node, which means it is a start node, so it will not go inside the while loop, but we need that node in our answer, right? Because we need to know from where we started. That is why we add that to our answer. Path is our answer. Okay, now you must have seen that first we added our a stop node, and then we went to their parent, their parent, their parent. Why we are going backwards? We want to go from what? Delhi to Mumbai, not from Mumbai to Delhi. So that is why the path which we have got, the answer which we have got is in reverse. So what will be the reverse of reverse? It will be our answer, right? So we reverse the path. Now we will get the path from Delhi to Mumbai. Earlier the path was from Mumbai to Delhi. That is why we needed to reverse it. Now we got the path from Delhi to Mumbai. We will print the path. It is just one of the fancy way of printing it. Okay, and we will return the path, and then we will move to this line. See, if we moved to this line from, let me check the indentation once. It is still in while loop. All right, now we remove the n from open list. Okay, if we reached here, which means we got we did what we wanted to do, right? Now remove the n. N is the what? A starting node. That was the first node which we added in the dictionary, if you remember. Now I removed it from dictionary, so there is no node in the open set. If there is no node in the open set, this while loop will stop, isn't it? Yes, it will stop. So we remove the node from open set and we add the node into the closed set, which means we want to say that, hey, don't go this path. We did what we wanted to do. We came out of the while loop. Here print path does not exist, okay, and return none. See, we will only reach this part of code if we have not reached this part, okay, because here now the program stops. If we return the path, the program will stop, it won't reach here. But if we never found the path, we never entered in this if condition, then that means we have tried to find everything, all the path, and the starting node is also removed in the previous step. We have nothing else to do, and that is why we print path does not exist. This may happen if this graph node was empty or something like that, and then this will be the edge case. Alright, now what is there? This I have already explained in the beginning, right? Get neighbor heuristic I have already explained, graph node already explained. Yeah, we got our answer, and see, this is the answer. Okay, now the most important thing what you need to know is that, do you need to know this algorithm? Like, see, I have seen many people who know 10 times more difficult algorithm than this and are yet jobless. See, knowing difficult things won't land you a job, but knowing things which people need will help you land a job. Or if you are wanting to start some startup or something, then it may help. If you are planning on becoming a front-end developer, then you won't be needing this. Alright, if you will need this, then the senior developers will give you some libraries, make use of this, that would be more optimized code and will cover all the edge cases in the real life. But no matter how much senior developer you becomes, you won't be needing this. You won't even need bubble sort, because front-end developers don't need algorithmic knowledge. What they need is to replicate whatever the Figma file they have been given. For that you don't need this much algorithmic knowledge. If you want to become a software developer or someone who is programming a specialist role or R&D team, or if in game development or machine learning, then this algorithm become compulsory and you should know it. Okay, in all the other scenarios you don't need this. You don't even need to bother about any algorithm, especially for front-end developers don't need to bother themselves with such a difficult algorithm. Now another algorithm which I will explain is not in this video, another video, is AOA star algorithm, and that video, when it will come, I don't know, but probably in a month or so. Alright, bye.